For number 1 on section 4.2, we're supposed to verify that the function satisfies the three hypotheses of Rolle's theorem on the given interval, then find all numbers C that satisfy the conclusion of Rolle's theorem. So we're given a function, we're given an interval, and if we look back up at the hypotheses of Rolle's theorem, number 1 says that f of A is equal to f of B. So your A and B are -1 and 1. Those are the interval numbers there. And if we take f of -1, so if you plug in -1 into the original, you should get 2. And then if you take 1 and plug it into the original, you should also get 2. So these numbers match. So condition 1 is met. The second condition, or the second hypothesis, says f is continuous on the closed interval a to b. So if we look at our function, that is defined on that interval. That is continuous on that interval. So f is defined and continuous on the interval. And then 3 is f is differentiable on the interval. So I need to take the derivative. So f prime is going to be equal to -2/3 x to the -1/3. And a different way to write that would be -2/3 x to the 1/3. And a big issue with this is that now with that x on the denominator, that is undefined at 0. So because our derivative is undefined at 0, and that is within that interval of -1 to 1, the derivative is not differentiable on that entire interval. Therefore, we cannot use Rolle's theorem. And that would actually be it for this problem.